the volume of a 1000-gram sealed packet in 150 centimeter cube. Will the packet float or sink in kerosene if the density of the kerosene is this value? What will be the weight of the kerosene displaced by this packet? We have to figure out the weight. Now, very first thing is, let's figure out if it sinks or floats. Okay, so we have volume of the object to be 150 centimeter cube. Again, it's very important to make a mental note of the values and their respective units. Not G, sorry, this is mass of the object. Since I told values and units, I wrote G off there. Okay, then we have density of the kerosene, which is 0.80 gram per centimeter cube. And the next step is, yes, figuring out the density of the object. So how will we do that? With the help of rho naught is equal to, or rho is equal to mass by volume. That's your general formula. Now we are looking at density of the object, which is equal to, therefore density of the object is equal to 1000 divided by 1500. 20 gets cancelled. Clearly this can be divided with 5. 5 2s are 5 3s are. So 1 by 3 is 0.3333. So 2 by 3 will be 0.67 approximately gram per centimeter cube. That's all we need. We don't need to convert anything over here. Right, guys? So what can we conclude? As density of the object is less than density of the kerosene, this implies the object will, yes, the object will float. The object will float. Okay, so it's floating. Now, how will we figure out what is happening over here? How will you figure out the weight of the kerosene displaced? Let me do this. We have the container with the kerosene. Okay. So this is your kerosene level initially. You just let the object, you just place the object on the top. What happens? Will it sink? No, it floats. That's what we concluded. And underline the word float. Again, it makes things easy for your teachers. So there will be some increase in, let me actually, just a second. Yeah. So when you keep the object, there will be some increase in the kerosene level, say this much. Remember, it's still floating. That would be the increase. But is it equal to V naught? Right? It's not equal to V naught clearly. Is it not? This volume is not equal to V naught. It's not equal. Let me write it clear. Yeah, it's not equal to V naught. You should be very clear with this. If it's not equal to V naught, how will we figure out the mass then, or the weight in this case? Well, since it's floating, the mass of the displaced kerosene has to be equal to the mass of the object. As simple as that. Okay, guys, that's the whole idea. Now let me come back. Let me write this. As the object is floating, this implies weight of the displaced kerosene, or displaced fluid. It has to be equal to, there's no other way. It has to be equal to weight of the object. As simple as that. So now what is the weight of the object? Mass of the object into acceleration due to gravity. And what is the mass of the object? 1000 grams. How do you convert it to kg? I can do it over here. 10 to the power of 3 into 10 to the power of minus 3 kg. Right, guys? So this will be 1. So 1 kg. So 1 kg into 10 meter per second square. So this will be basically 10 Newton of force. So that would be the weight of the kerosene displaced. Okay. So weight of kerosene displaced is equal to 10 Newton. That's your answer. Okay guys, that's it. As simple as that. Right, so now you guys have to make a note of everything. It's important to make a mental note of this as well. In exam you need not draw this, but let's get used to such things. Mentioning not things also, because you should not get confused. So do copy this. Yeah, and everything else by default you guys have to copy.